So in this problem, we are studying the Kundt method for measuring the speed of sound. So we can see in this figure we have a rod R that is clamped at its center. A disc D at its end projects into a glass tube that has cork filings spread over its interior. And we have a plunger P that is provided at the other end of the tube, and the tube is filled with a gas. The rod is made to oscillate longitudinally at frequency f to produce sound waves inside the gas, and the location of this plunger P is adjusted until a standing sound wave pattern is set up inside the tube. Once the standing wave is set up, the motion of the gas molecules causes the cork filings to collect in a pattern of ridges at the displacement nodes. If f equals 4.46 times 10 power 3 hertz, and the separation between the ridges, let's name it D, is equal to 9.2 centimeters, what is the speed of the sound in the gas? So if we look again at this experiment, we are told that these ridges are formed at the nodes. So if we remember the drawings of the sound waves, these are at the node locations. So you can imagine that the sound waves will be as such. So this is our first node, for example. This is our second node. So this is at the node location. We have these ridges that are forming due to our wave. Now, this distance that we are given, which is 9.2 centimeters, it will be basically the distance between two successive nodes. And if this is the distance between two successive nodes, we can observe that for any two nodes, the distance between them is actually equal to half the wavelength, because this is a full wavelength. So this is going to be equal to lambda over 2. And so from this distance d, we can find lambda, which is 2d, which is 2 times 9.2 centimeters. And finally, we can deduce the speed of sound in this gas, because it will be lambda times the frequency. We are given the frequency that gave us these standing waves. And so we will get the speed to be 821 meters per second in this situation. In the link here, you can check for the standing waves that are forming. So we have the experiment that is done here by Kundt for measuring the speed of sound. The frequency is adjusted inside an air tube. And then what happens is that at a certain frequency, standing waves will form, and you can see the ridges which will form at the locations of the nodes where we have these standing waves.